So we were discussing about the exponential growth and decay modeling. In the last lecture, we have talked about the exponential growth model. We have already discussed about what you mean by the linear growth. We have discussed what you mean by the linear growth, and we have also discussed what you mean by the exponential growth in detail. Then we have considered one population model in which we have calculated that the population at time t is equals to the initial population when the time is being considered as 0. And then if we have a rate at which the population is growing in terms of a decimal, and if we know the time for which the population growth is to be known, then the total population can be calculated. Do you have any question regarding this model? Do you have any question regarding this model?
No, sir.
Now here in this model, here we have a plus sign. If you see that in this model, we have a plus sign. Mind it, whenever the value for r is greater than 0, the function is exponential growth function. And when r is less than 0, the function is same exponential, but now this time it becomes decay. That's a decreasing. So remember this equation. I will use the same equation. In spite of this plus sign, I will consider a negative sign. By using this plus sign function here, this is the plus sign function. If the initial population was 3,000 and the annual growth rate is 8%, if we convert the 8% into the fractions, that will be 0.08. And as per the numerical, what will be the population in 2027? And the initial year is 1917. So the difference between the years is 110. So we consider time as 110 years. If we place the time as 110 years over here, the value for r, the growth rate is 0.01, and this one will be plus in it, so it becomes 1.08 as in total. And we take a power for that 110 and multiply with the 3,000, we have a very larger number. The total population is 14.25 million people. Now mind it, here we have used a plus sign in the same model. Let's move to the second part for this presentation is exponential decay. When we call about the growth, so this is, we have a x-axis and this is, we have a y-axis. In y-axis, we have a population, and on x-axis, we have a time. If you look into this blue color curve, which is drawn on the graph, here you can see that as the time is increasing from 1, 0, 1, 2, 3, you can see that the population is decreasing. So the decay model is that model in which with the passage of a time or with the passage of a horizontal axis, the vertical axis decreases. Now let's consider the same equation. Now this is the same equation for the population, but here you can note that we have a negative sign. This negative sign indicates that it's a decay. decline. In this, as the time increases, the population decreases beyond the initial population. Now let's talk about the exponential decay problem, one of the numerical. Let's say that the initial population of the bacteria, this time we have considered the bacteria, not the humans, we consider the bacteria. The initial population of bacteria in a wastewater was found as 10 million. So the P naught is 10 million. The aerobic treatment was given to the wastewater to diminish the bacteria in order to kill the bacteria, to reduce the bacteria. We have used aerobic treatment, that we have supplied the oxygen or the air. And the rate at which it is decreasing is very much quicker, as a 2.5%. And the time say that what will be the population after 5 days. So in this numerical, we say that P naught is 10 million. So we have a 10 and 10 power 6. So this is the initial population for the bacteria. This one is for the formula, this negative sign. And if we convert the 2.5% into the fraction, we have to divide 2.5 with the 100. So the answer becomes a 0.25. 1 minus 2.5, it will be a lower than a 1. If we consider power to that, this will decreases. This will have a shorter value as compared to the previous one. So the total population which is available at the initial stage when the time is 0 is 10 million, now decreases to 8.81 million. Yes, do you have any question? Did you understand that?
Sure.
So what is the difference between the growth and decay model? We have used the same equation. What is the major difference in the equation in the model? What is the major difference? This is the decay model.
साइन
No,
का
no.
डिफरेंस है आंसर, यहाँ पे कांस्टेंट नहीं है के।
अच्छा, के तो हमने वो लिया ही नहीं ना, हमने कहा कि एक हमारे पास ये वाला मॉडल है। एक ये वाला मॉडल है पॉपुलेशन का, ह्यूमन पॉपुलेशन का। इन दिस ह्यूमन पॉपुलेशन मॉडल we have a plus sign over here. This plus sign indicates that this is the growth model, यानी पॉपुलेशन बढ़ेगी। अब सेम मॉडल ये यूज होगा। look at that model, p of t equals to p naught 1 plus r power t, same model use होगा, but this time we have a negative sign. Here you can see that the model is exactly same, except we have here we have a negative sign. This negative sign shows that the model will decay, decreases. इसमें k वाला नहीं है, यहाँ पे है ग्रोथ रेट r. Yes, is it clear?
ओके सर।
k वाला जो प्रॉब्लम था वो ये वाला था, in which we consider that we have a bacterial population, the total n equals to 250 exponential power k into t, that we have discussed in the last lecture. Now this is the equation number 1. I said that, okay, mark it as equation number 1. Now, considering this equation, we have one initial condition given. कि टाइम 10 घंटे, 10 घंटों के टाइम के बाद दी bacterial population, now this is the initial population, 250 is the initial population. Bacterial population is increased to 280. अब ये कह रहा है कि estimate the time when the bacteria becomes double, यानी n जो है वो 500 हो जाए. So if we look into this equation number 1, in this equation number 1 we have three unknowns. N is unknown, K is unknown, T is unknown. The three unknowns are there. Here the K is a growth rate, T is the time, and N is the number of population. But as we have given the initial condition, initial condition क्या है, एक bound condition की दी हुई है that when the time is 10 hours, then the population is 280. So in this model, equation number 1, where the n is there, we will put 280. And when the t is there, we will put 10. So remaining will be the value